So in this video we will be seeing how to hide any process from the user mode processes. So the task manager, for example, will monitor all the processes in our system each second and will retrieve the information. So it will use the NT-query system information function, and here we need to pass the system information class, which is an integer, to specify what type of information we want. And the next one is the buffer length, buffer pointer and buffer length, and the return length if the buffer length is lesser than the returned length. So these are the various values for the function: system basic information, exception information, etc. What we are interested is in the system process information. So returns an array of system process information structures, one for each process running in the system. So this is the structure, and it will return an array of these structures. You should also notice that beside the system process information there will also be multiple number of system thread information. So that's why there is a field called next entry offset in the system process information. If you add base address to this next entry offset, you will get the next process information, and if you add the next process information plus the next process next entry offset, then you will get the third process in the array or list. So here there is a description: the start of the next item in the array is the address of previous item. So if you want to find the next item, you need to add the base address of this current process and the next entry offset. So is the address of previous item plus the value in the next entry offset member. So this is how you enumerate all the process. So I have drawn a diagram. So this is the first process information and the next entry offset. So if you add these two values, you will get to the next process information, and it also contains the process name, and if you add these two you will get the next one, and so on. So this is how we enumerate the processes. Now what we are going to do is, if I want to hide joplin.exe, then what I am going to do is I want to change this offset to this offset. So if you change this offset value to some other process that is beyond after this joplin.exe, then what we can do is we can override this with the value of this one, so that the user mode process will, when parsing, will ignore this joplin.exe. So this is what we are going to do. So this is these two processes are side by side, joplin.exe consecutive. So if the next proc info.image name is joplin.exe, we move further and we check again if this is joplin.exe, and we move further and we check if this is joplin.exe. No, it's not. So it's chrome.exe. Then that means we need to add these two offsets. So here we have the offset pointing to this one, and if you add these two offsets to this offset, then you will get the offset to the third value, so this one. So we will keep on adding until we do not get this joplin.exe. So here I took joplin.exe for example. So we will be looping over this next process information structure and check if it's targeted process name. We move further and we keep on adding the offset, and we will override the offset at here. So this offset will be pointing to the this one, third one, ignoring these two. So this is what the theory is. So let's first see how to call this anti-query system information. So this is not straightforward because the process information is very volatile. It keeps changing from every second. So we need to do what we need to is we need to do an infinite loop on this anti-query system information, and we will stop only if we got the status success as a return value. So let's declare a buffer. And we are going to call the anti-query system information. So in this class, the value for the system process information is 5. So 5, and the system information buffer, and the system information length is buffer dot length, and the return length is ampersand mute required size, that is rec size. Now what we are going to do is let's store this value in the anti status variable. So we are going to do the infinite loop. If anti status is equals to status success, then only break the loop. And also while breaking, throw the buffer value to the here. So let buffer. So now we are good to go. So we have declared a required size as 0, and in the initial call, in the first call, we will be passing the buffer pointer and the buffer length and the required length. This fails because the 0 because the length of buffer is 0, so it tells us the required size in this variable. And again in the loop we are allocating the buffer of the required size, and we are calling this again. We will be doing the same process until we get the status success. So we can actually print the required size. So let's go and run this, and you can see this is the required size. Okay, now we got the required size. Let's go and parse the process names. So let's let mute first info is equals to buffer dot as mute pointer as usize. So the buffer variable now contains all of these structures. So we are storing the initial address in first info, and we need to remote parse this. So this is the function I have written. So what it will it does is it will allocate the structure size of t is the generic, and it will try to read that much amount of size, the structure size, from the base address in the process handle, and it will return the structure. Get current process, the base address is first info as constant c void, and parse this one as system process information structure. So let's say this as first proc info. So in this we have the image name, that is the Unicode string. We can use the Unicode string. It's just a buffer. We need to read the length member value of bytes and parse that as a string. First proc info dot image name, let proc name, and we need to trim the null bytes at the end. Dot to string. So we have got the process name. So this is for the first process, that will be system process. Now we need to loop all over the processes. So loop now we need to increment this first info plus is equals to first proc info dot next entry offset as usize. So we are adding the next entry offset to this first proc info address, so which will point to the next proc info, and we need to define the actually let's remove this first in the first proc info, because it's very confusing, because we'll be keep on moving, right? So let's call this as proc info. Okay, we are good to go. Now if proc info dot next entry offset is equals to 0, then break. So the documentation says for the last item in the array, the next entry offset is 0. So you can actually cut this one and paste here, because we are printing the last process name and then checking if its next entry offset is 0, then breaking. So now we are good to go. Let's go and run this one, and we can see all of the processes. Now let me open the Joplin. So why I choose this is because there are multiple instances of joplin.exe consecutively. So let's go and run this again, and now let's grep this one for Joplin, and we can see there are 4 processes. Okay, so this is our base program. Let's remove this one, remove the print line, and let's run this. We should see no output. Now what we are going to do is we are going to inject the DLL. So I have done some modifications to the IAT hook function. I have thrown the parameters. So instead of directly checking the user30.dll message box here, I am passing this as a parameter. So it will search for source DLL and source function, the legitimate function, and our malicious function. So the parameters will be follows. So the first 2 parameters belong to the which function you want to hook, that is ntdll and ntquery system information, and you want to redirect to which function, that is myhooking.dll and myquery sysinfo. And here in the static variables, we have the message box address, which is the original address of the function, and malicious message box address is the malicious function we are going to execute. And the first thing, and the test one contains the IAT address, the first thing address, where we need to where we have overwritten the malicious address. So we have read 8 bytes from the first thing pointer and stored this in the test one. So it's just like a previous videos. Okay, now whenever the application call this function after hooking my query sysinfo, all the parameters will be passed on to this function. So the system information class and the buffer pointer and the buffer length and the return length. So that means we need to call the anti-query system information function with these parameters, and we need to modify the data pointing at this buffer. So because this buffer will be later processed by the application like task manager after calling this function. So this buffer is very important. We need to modify actually in this buffer. So the task manager after calling this function will take this buffer pointer and tries to parse all the processes. So we need to modify the next entry offset here in this buffer to hide any process we want. So we need to first filter some of the conditions. So there are other types of information we can retrieve. We are only focused on the system process information. So that means we need to say if system information class not is equals to 5, that means that is not, if that's not equal to system process information, then we need to return. So in the return we need to call the anti-query system information, but what I'm going to do is we have this message box address, that is the valid anti-query system information address. So I am going to convert this into a function pointer. So copy the function signature and paste here. Okay, remove these variable names. We just need the function signature and we are good to go. So yes, it's U32 and this should be star mute U32. Yes, let's call this as my query. Now we need to, if the application okay, let's remove this comma. So if the application did not call for system process information, we need to return as it is. So my query of and change this to my query. So this is system information buffer. So we are good to go. So we are ignoring all of the requests other than system process information. And there is also another thing we need to check, that is the empty status. So here you can see we are calling infinitely this function until we get the status success, right? So what we are going to do is we are going to call this function let empty status is equals to, let's actually execute that function and check if it's empty status not is equals to status success. So what this means is the application like task manager has called this function with incorrect information, like buffer length is 0, just like our valid function. So here first we have sent the 0 length, we got the error. So that's why we need to ignore these cases and we need to check only if it's status success. If the empty status is status success, then that means this function, our empty query system information function, has written all the valid information at this system information buffer. So if the status is not success, then we are going to return empty status. So that's it. Now here in this space, then that means the empty status is success. What we are going to do is we can just try to copy this one and paste here. Instead of buffer, we can say system information buffer. So let's actually print this one. So we are just doing nothing, we are just printing the process names. The buffer is already allocated at this system information buffer variable, we are just printing the values. And also remember, in this process, in the valid application process, we are not printing these values. So let's go and hook the DLL. And if you run this one, you should not see any of the output, but we will see the output because the DLL is printing out the values. So you can see we got successfully hooked our DLL and it is printing these values. You can also confirm like process name from DLL, something like that. You can see from DLL. Okay, now what we need to do is we need to say let mute offset is equals to proc info dot next entry offset as usize. So we are copying the the current offset in a variable, and we will do an infinite loop to check if the next process is Joplin, then we will be adding this offset and this offset. And if the next process is also Joplin, then we will add this offset to the previous these two values. So we will go on until the next process is not equal to joplin.exe, and we will overwrite the offset values at this address, which should point to the process next to joplin.exe. So let's go and do that. So we have the offset, so loop, let's call this as inner loop. So let next proc info is equals to, so copy this remote parse, and here at the first info we are going to add the offset, press offset. So basically we are first info, the offset is current offset, we are adding these two values to get to the next proc info. And we can also copy this one, paste here, change this as next proc info, and next proc info. We are retrieving the image name, the process name. If next proc name dot to lower case is equals to joplin.exe. Okay, we can say not is equals to joplin.exe, then break. So if this is not a joplin.exe, we don't need to move further, we can just directly break the loop and break the inner loop. And here the code will be executed if the next process name is joplin.exe. If the next process is joplin.exe, we need to add the next process offset to our current offset. So offset plus is equals to next proc info dot next entry offset as usize. Okay, we are adding to this offset. So this process will continue until we do not get the next process as joplin.exe, which is this one, and up to at this point the offset value variable contains the addition of current offset, this joplin.exe offset and this joplin.exe offset, and it will stop at this point. So if you add all of these offsets to this first process info, then we will be pointing to the chrome.exe. Okay, so we just got the offset value, we need to overwrite at the first proc info, that is the current process base address. First info, so each and every time we will be writing, we can put a condition that, so since we are initializing the offset to the current next entry offset, we can say if offset not is equals to proc info dot next entry offset as usize, then that means this offset has been changed, then we are overwriting the value. We should also do virtual protect to change the memory protections. We can say page read write execute, Okay, now I think we are good to go. Let's go and run this, and now we should not see joprint.exe. Okay, we did not build the DLL, and here there is joprint.exe, and I think there is still the joprint.exe. Okay, we did something somewhere wrong. So we have overwritten the first this offset. I think we need to continue this here. Okay, so change this one to offset. So after changing the values, we are again looping here. So offset, this should do good, because we have overwritten the here, and we need to add offset size, not the first entry offset, because this will always point to the next one. So let's build this, and we can see there is no joprint.exe. So you can see there is no joprint.exe, and we can also do that for notepad as well. Just change this to notepad.exe. And we can see there is no output. Now let's go and inject this DLL into task manager process. So I have already written the simple DLL injector, and we need to run this DLL injector as admin. So before that, let's open task manager, details, so the process ID is 23032. So we are opening the process handle, and we are fetching the address of load library, and then allocating the path of this myhooking.dll, and writing that path bytes, and creating the thread at load library A with the argument our DLL path. So now where is the notepad? So here there is the notepad. Upon running, we should not see notepad.exe, and we can see there is no notepad.exe. You can check that note, so there is no notepad.exe. So we can do this as chrome.exe as well. Okay, this was open in this task manager. (10408). So we have chrome.exe. So let's run this, and we can see there is no chrome.exe. So chr, nothing. So that's how you can hide the process from any user and process. And there is one more condition. If this next entry offset is 0, if it's 0, then that means this next entry offset should also be 0. So we can also write that condition as well. If next proc name dot next entry proc info dot next entry offset is equals to 0, then that means copy this, paste here, okay, we are good to go. We are overwriting the next entry offset at the first proc info to 0. Okay, so that's how you can hide any process you want from any user mode processes.